Alright, welcome back. We are on section 3.1. Let's see, this is part 2. And moving on to example, so 3.1, part 2, example 4. So use the integration by parts to evaluate the integral of the arc cosine of 2x dx. So what we're going to do with this one again is we only have one type of function. So we're going to set that equal to u, and then the dx will equal dv. So we have u is equal to the arc cosine of 2x, and dv is equal to dx. All right, so now we can find the derivative. So the derivative of the arc cosine of 2x, and so you can have your purple sheet or whatever you need there, but that derivative is going to be 1 over the square root of 1 minus, in parentheses, 2x squared, and then remember our chain rule, we'll have to multiply that by the derivative of the inside also, so we'll have to put a 2 up there, and then dx as well. Okay, then the integral of dv is going to be v, and the integral of dx is x. Okay, and so we're ready to go. So now we've got u, which is the arc cosine of 2x, times v, which is x. Put that out front. uv minus the integral of v du. Can pull this 2 out in front, and then this x we can put in the numerator. So we're going to have x over the square root of 1 minus 2x all squared dx. Alright, so you first might be tempted to look at your integration sheet or your derivative sheet and see if this is an easy, inverse trig substitution or something like that. However, it is not. And you may remember that we did do some problems like this back when we were doing u substitution. So what we're going to do, I'm going to use z again since I've already used u. So let's go ahead and say z is equal to 1 minus 2x squared. So that's everything underneath the radical right here. So this x up here actually gives us some more freedom to use some substitution here. So then the derivative of this, let's rewrite that a little better here so we can take the derivative. So 4x squared. Okay, so dz is going to equal negative 8x dx. Right? Now we do not have an 8 over here that we can substitute in, but we do have the x dx, so that's where that x dx will go. And the 8, we can bring over here. So negative 1/8 dz. dz is going to equal negative, nope, we took care of the negative, x dx. Okay, so we can replace all of this for the x dx, put in its place. And then everything underneath the radical will just be z. So I'm just looking at this portion right here. Okay, we'll come back and make sure we bring the rest of that equation along. So the integral of this right here, we're going to do a substitution. So now we have the integral of, where are we? So that x dx is all negative 1/8 dz, okay, and then 1 over the square root of z, and then we still have the dz. Okay, so that's simplified down to a really nice integral. So now let's go ahead and find the integral of that. So negative 1/8. This is z to the negative 1/2. So add 1, divide by that number, So we're going to have to multiply by a 2 out in front times z to the 1/2, which is the square root of z. Okay, so that all simplifies down to this. Let's go ahead and simplify that fraction too. So we have -1/4 square, -1/4 square root of z. Okay, and so now we can go back and we can plug that in up here. So now we have that equals x arc cosine of 2x. Okay, and then that's going to become a plus. So we're going to plug this right in here for that. So we still got this -2. So that's going to become a plus 1/2. And then square root of z. Oh, we need to plug z back in. Let's plug z back in right now so we don't have to write it all over again. What is z? Z is 1 minus 2x squared. Perfect. And then plus c. We could have also wrote the 4x squared, this one down here too, but either way is good. Okay, and then that's our solution. Okay, I was off by a negative there, so I had to go look real quick. It seems that we missed a negative way up here, which you probably saw. So this should have been a negative here, which would have made that a positive. And then when we plugged back in down here, this one here would be a negative. Okay, perfect. Now we're good. Okay, on to example 5. Okay, I really wish I'd left myself more room here for some of these. This is another very interesting one. Show you a little bit of a different trick. This is the last example that I'm going to do for your notes. The rest of these, I believe that you guys can figure out on your own. I want you to work with those and figure them out on your own. So let's look at example number 5 though, because this one is another type of trick that we do with the integration by parts. So we're starting off with the integral of sine of the natural log of 2x. So again, this is not the product of two functions. It's actually the composition of functions. So we're going to, again, say u equals sine of the natural log. And actually, I'm gonna write that up here, because I definitely think I'm going to need a lot of room for this one. Okay, so u equals the sine of the natural log of 2x, and then that'll be u, and then let's say dv equals dx, so therefore v equals x, and then over here we are going to have du, the derivative of sine is cosine, times the derivative of the inside. The derivative of the inside will be 1 over 2x times 2, so the 2's will cancel out, so it'll just be over x. And then dx we need in there too. Okay, so there's our first substitution for integration by parts. So we have v, so this integral here is going to equal the sine of the natural log of 2x times x, so u times v, minus the integral of v, du, okay, so see what's going to happen with our x's here, and then dx. Okay, so our x's are going to cancel. And now what you notice here, we have an equation now, taking the integral of an equation that is really not much different from what we started with. However, watch what's happened. So we're going to do this again. I'm going to do this one in red. So we're going to take this integral again, just what I have there in red, and we're going to say that u equals cosine of natural log of 2x. Okay, and then dv is equal to dx, so we're doing the same thing again. Okay, so u, or du, take the derivative of this. Derivative of cosine is negative sine of natural log of 2x. Again, take the derivative of the inside. The 2's will cancel, and we'll have just x in the denominator. Integral of dv is v. Integral of dx is x. And now we're ready to write this one out again. So now we have just this part here is equal to uv, so cosine of natural log of 2x times x, I'm going to put that out in front, minus the integral of v du, which is negative sine, so I'm going to cancel out my sign there, and then have the sine of the natural log of 2x over x. Okay, x's are going to cancel. Oh, we got a dx in there, don't forget our dx. Okay, so what we're going to do now, so we're taking the integral of this again. Notice we're just kind of going in circles, it seems like, right? But what do you notice about our integral now? Now we have this integral. I'm going to rewrite it. This is the integral of the sine of the natural log of 2x dx. So this is really what we started off with. So this is our answer. Okay, so I'm going to write everything out, including my answer. So we have the integral of the sine of the natural log of 2x dx is equal to this first part, the sine of natural log of 2x times x, I'm going to pull that out in front, minus the second integral that we did, which is all of this and this, so minus x cosine of the natural log of 2x, and I'm going to put this in brackets here because I'm afraid I'm going to lose out on that negative there, and then plus the integral of the sine of natural log of 2x. Oh, go away. I know I've got a meeting coming up. 2x dx. Okay, I'm going to come back on my bracket here. Let's not worry about that bracket. Let's just go ahead and distribute. So it'll just be through that negative, and then that'll make that negative there. Then we don't need to have that bracket here. Okay. So now, this is the tricky part. We have our integral here on the left-hand side. We also have that same exact integral over here. So I'm going to combine like terms. I'm going to add this to both sides, which is now going to give me 2 times the integral of sine of natural log of 2x dx equals all of this. Then what I'm going to do, divide both sides by 2, and then I'm done. And I have my answer. So we have x sine natural log of 2x minus x cosine of natural log of 2x. I added this to the left-hand side. Now we have 2 of them. Let's divide both sides by 2. And then you have your final answer. Our 2's cancel on the left-hand side. And now this is exactly what I wanted to find the answer to. And that answer is what we have on the right-hand side. We could also pull that 1/2